Hello everyone, today we're going to discuss a special type of distribution under the discrete random variable, which is the Poisson distribution. A widely used distribution emerges as the number of trials in a binomial experiment increases to infinity, while the mean of the distribution remains constant. Consider the following example. Wire floss. Floss occurs at random along the length of a thin copper wire. Let x denote the random variable that counts the number of flaws in a length of t millimeters of wire, and suppose that the average number of flaws per millimeter is lambda. We expect that the expected number of flaws is equal to lambda t from the definition of lambda. The probability distribution of x is determined as follows. Partition the length of wire into n subintervals of small lengths delta t equal to t over n. If the subintervals are chosen small enough, the probability that more than one flaw occurs in a subinterval is negligible. Furthermore, we can interpret the assumption that flaw occurs at random to imply that every subinterval has the same probability of containing a flaw, say p. Also, the occurrence of a flaw in a subinterval is assumed to be independent of flaws in other subintervals. This can be generalized to include a broad array of random experiments. The interval that was partitioned was the length of wire. However, the same reasoning can be applied to an interval of time, an area, or a volume. For example, the counts of particles in a contamination in semiconductor manufacturing, flaws in rolls of textiles, calls to a telephone exchange, power outages. Atomic particles emitted from a specimen have been successfully modeled by a probability mass function in the following definition. In general, consider the subintervals of small length delta t and assume as delta t tends to 0. The probability that more than one event in a subinterval tends to 0, the probability of one event in a subinterval tends to lambda delta t, and the event in each subinterval is independent of other subintervals. A random experiment with these properties are called Poisson process. Poisson distribution. Then we can model the distribution of x as approximately a binomial random variable. Each subinterval generates an event flaw or not. Therefore, the expected value of x is equal to lambda t equal to np. And one can solve for p to obtain p is equal to lambda t over n. From the approximate binomial distribution, the probability for a binomial distribution is n combination x p raised to x times 1 minus p raised to n minus x. Taking the limit with a small enough subintervals, n is large and p is small. Basic properties of limits can be used to show that as n increases, n combination x lambda t raised to x all over n approaches lambda t raised to x over x factorial, where 1 minus lambda t all over n as raised to negative x approaches 1, and 1 minus lambda t over n raised to n is equal to e raised to negative lambda t. Therefore, the probability for x is equal to e raised to negative lambda t times lambda t raised to x over x factorial for x is equal to 0, 1, 2, and so on and so forth. Because the number of subintervals tends to infinity, the range x, the number of flaws, can equal to any non-negative integer. These are some of the graphs of a Poisson distribution. With lambda is equal to 0.1, the graph is like this. While when lambda is equal to 2, and when lambda is equal to 5, it tends to be a little bit more normally distributed. The sum of the probabilities is 1 because the summation of e to the negative lambda t times lambda t raised to x over x factorial for x is equal to 0 to infinity is equal to e raised to negative lambda t times the summation of lambda t raised to x over x factorial for x is equal to 0 to infinity. And the summation on the right-hand side of the previous equation is recognized to be Taylor's expansion of e raised to x evaluated at lambda t. Therefore, the summation equals e raised to t and the right-hand side equals 1. Use consistent units for lambda and t. For example, if lambda is 2.3 flows per millimeter, then t should be expressed in millimeters. If lambda is 7.1 square centimeters, then an area of 4.5 square inches should be expressed as t is equal to 4.5 times the conversion factor 2.54 squared equal to 29.03 square centimeters. The random variable x that equals the number of events in a Poisson process is Poisson random variable with the parameter 0 less than lambda, and the probability mass function f of x is given by e raised to negative lambda t times lambda t raised to x over x factorial for x is equal to 0, 1, 2, and so on and so forth. The mean and variance for a Poisson random variable. If x is a Poisson random variable over an interval of length t with the parameter lambda, then the mean is the expected value of x equal to lambda t, and the variance v of x is equal to lambda t. The number of content changes to a website follows a Poisson distribution with mean of 0.25 per day. So for this problem, we have lambda is equal to 0.25 per day. We are looking for t with a unit days. What is the probability of 2 or more changes in a day? What is the probability of no content changes in 5 days? For letter A, what is the probability of 2 or more changes in a day? So given that t is 1 day, we're looking for the probability of 2 or more changes. So x is 2 or more. So 3, 4, and so on and so forth until infinity. So since we have lambda is 0.25 and t is 1, so lambda t is 0.25. So f of x is given by e to the negative 0.25 e to the negative lambda t times lambda t raised to x over x factorial. So we're going to have the summation of f for x is equal to 2 to infinity. And that is the probability that we're looking for. But take note that x takes values 0, 1, 2, 3, 4, 5, and so on and so forth up to infinity. So since we are looking for 2 to infinity, it is just the same as taking the complement of this, so that's 1 minus, and get the probability of 0 to 1. So it would be the summation of e to the negative 0.25 times 0.25 raised to x over x factorial for x is equal to 0 to 1. So we can evaluate this using our calculator. This would give us a value of 0.0265. Do you get the same value? What is the probability of no content changes? So x is equal to 0 in 5 days. So t is 5. So this is a probability equal to e raised to negative 0.25 times 5 times the quantity 0.25 times 5 raised to 0 over 0 factorial. This is equal to 0.2865. I hope you get the same answer. Last problem. What is the probability of 2 or fewer changes in 5 days? So x is 2 or fewer. So that's 0, 1, or 2 with t equal to 5. So the probability is the sum for x is equal to 0 to 2 of e to the negative 1.25 times 1.25 raised to x over x factorial. Where did 1.25 come from? Correct, it is 0.25 times 5. So, if we will be evaluating e to the negative 1.25 times 1.25 raised to x over x factorial from 0 to 2, it would be equal to 0.8685. More examples. The number of telephone calls that arrive at a phone exchange is often modeled as a Poisson random variable. Assume that on the average there are 10 calls per hour. So lambda is 10 per hour, meaning t should be in terms of hours. What is the probability that there are exactly 5 calls in 1 hour? So x is equal to 5 when t is 1. What is the probability that there are 3 or fewer calls? So x would be 0, 1, 2, or 3 when t is 1 hour. And what is the probability that there are exactly 15 calls? So x is 15 in 2 hours. So for the first one, the probability is equal to e to the negative 10 times 1 times the quantity 10 raised to 5 over 5 factorial. So that's e to the negative 10 times 10 raised to 5 over 5 factorial. It's 0.0378. For the second one, what is the probability that there are 3 or fewer calls in 1 hour? So the probability of 3 or fewer, so x is from 0 to 3 of e to the negative 10 times 10 raised to x over x factorial. So that is 0.0103. Next, the probability that we are looking for here is e to the negative. So x lambda is 10, t is 2, so e to the negative 20 times 20 raised to 15 over 15 factorial. So this is 0.0516. What is the probability that there are exactly 5 calls in 30 minutes? So 30 minutes is half an hour, so t is 1 half. And then x is 5. So the probability is now e to the negative 10 times 1 half is 5 times 5 raised to 5 over 5 factorial. So this is 0.1755. Let's try to work on this. So I want you to work on this and let's discuss the answers of this one in our online meeting. For the summary, we can have a continuous and discrete random variable. We have the probability mass function, the cumulative distribution function, the mathematical expectation, mean and variance. Under special types of discrete random variable, we have the discrete uniform distribution, binomial distribution, hypergeometric, geometric, and negative binomial distribution, Poisson distribution. These are the references we have for this topic.